It is not strange nor recent for the universe to experience cosmic dances. The emergence of several galaxies millions of light years from Earth as a result of these timeless occurrences. Scientists are currently keeping an eye on a cosmic dance that may herald the start of a new era for our galaxy as well as provide a glimpse into its future. Welcome to Zeey. In today's video, we'll be discussing about a pair of extremely aggressive black holes that have been found in space. Gravity is responsible for a lot more things in space than it is on Earth, such as binding our feet to the Earth and causing apples to fall on our heads. In the universe, gravitational forces are known to keep planets in their orbits, but they may also occasionally cause a great deal of disorder. Gravity has the power to crush gas and cosmic dust into blazing stars, crash errant cosmic objects into planets, and frequently push galaxies in the direction of one another until they eventually collide and produce galaxy mergers. Several galaxies can join together at times. The collision of 4 elliptical galaxies led to the formation of the greatest known merger. When galaxies collide, their contents are thrown out of equilibrium and they mix together to form one massive galaxy. Every merger in the cosmos is in a different stage of merging. Some are further along than others. NGC 7727, the merger of interest to us, is still a long way from becoming a single, enormous dazzling ball. William Herschel, a British astronomer, made NGC 7727 his own in 1785. One of the strangest galaxies in the Aquarius constellation, NGC 7727 contains far less gas, including neutral and molten hydrogen, than other merger galaxies in the same constellation. Around 1 billion years ago, 2 spiral galaxies collided to produce NGC 7727. The leftovers of the 2 galaxies from which it arose, including a number of plumes and oddly structured streamers, make up the merger galaxy. The dramatic relaxing phase that all merging galaxies go through is what gave NGC 7727 its high thermal energy and entropy. The parent universe's forms change during the collision, changing how the stars' individual orbits in their separate galaxies spin. The stars eventually merge, losing all awareness of their orbits and changing their once-ordered motion into random motion and heat energy. In elliptical galaxies, which scientists anticipate NGC 7727 will be in the near future, this chaotic and intricate orbit of stars is observed. The galaxy will likely end up with very little interstellar dust and star formation as its gas levels decline, according to scientists. Since NGC 7727 may provide a glimpse of what will happen when our Milky Way collides with its neighbor, the Andromeda Galaxy, billions of years from now, scientists have closely watched it. When using the Very Large Telescope, VLT, to observe NGC 7727 in November 2021, researchers discovered that the merging galaxy contains 2 galactic nuclei at its core. A supermassive black hole from one of the parent galaxies is enclosed in each nucleus. A well-known illustration of binary black holes is the pair of supermassive black holes at the heart of NGC 7727. They are one of the pairs of binary black holes closest to Earth, separated by 1,600 light-years and positioned 89 million light-years distant. While not being extremely side-by-side, these black holes are sufficiently close to one another to be affected by gravitational attraction. These twin black holes are literally circling each other like fighters in a ring at the core of NGC 7727, where they are engaged in a cosmic dance. The black holes have masses of 154 and 6.3 million solar masses, respectively. For comparison, the Sun has a mass of 1,030 kilograms, or 1 solar mass. It makes sense why they are called supermassive. The gravitational pull that the galaxy's black holes experience from both their own gravitational pull and the surrounding matter causes this cosmic dance. The smaller black hole is held in orbit because the latter is so powerful. telescopically seen black holes appear to be in the inspiral phase, the initial stage of their life cycle. The black holes pull toward one another during the inspiral phase. Because to the enormous space between the black holes when the galaxies first merge, this phase lasts the longest. Because of this separation, their gravitational pull on one another is weak, but gravitational waves are still generated. These waves will eventually lead the black hole's orbits to contract over time. The angular momentum is another element that influences how quickly black holes gravitate towards one another. The supermassive formations interact with cosmic components that may be in their path as they travel across space. Their speed is decreased as a result of this interference, which lowers their angular momentum. The orbit of each black hole contracts as this inspiral phase goes on, resulting in the production of stronger gravitational waves, which in turn generates greater speed until they are brought noticeably closer to one another. In the next 250 million years, these dual black holes, which have been in the inspiral phase of their life cycle for at least 1 billion years, are expected to transition to the merger phase, exactly like their parent galaxies. Scientists are keenly observing the evolution of these black holes as their separation gradually decreases over time. Dr. Karina Vogel, an astronomer at the Observatoire Astronomique de Strasbourg, said, "It is the first time we locate two supermassive black holes that are this close to one another, less than half the separation of the previous record holder." Although 250 million years may seem like an endless period of time, they are actually quite brief in the scheme of things. These two black holes are expected to merge to form one enormous black hole, and as a result, strong low-frequency gravitational waves will be generated. There is no question that this will be a violent event, a rush of energy through time and space. The first gravitational wave to be discovered in space occurred in 2016. This discovery later served as the cornerstone of the theory that some black holes in space were created by the merger of two smaller black holes. We now know that black holes, which have extremely strong gravitational fields, are created when stars collide under the force of their own gravity. Black holes in space are essentially the end of the road, sparing only particles with extremely low densities, like light. The activity of stars and other cosmic objects surrounding black holes, which are invisible to the human eye because they don't reflect light, is used to study them. It is impossible to envision exactly what would occur if two of these behemoths collided. There hasn't been a black hole collision in our lifetime, and according to projections, the next one won't happen for 10,000 years. There are, however, hypotheses that outline the expected appearance of black hole encounters. When each black hole's orbit becomes more compact at the conclusion of the inspiral phase, the speed of rotation of a black hole may increase up to anywhere between 1/3 and half the speed of light. When they ultimately crash, the kinetic energy that is built up would be violently transformed into sound, light, and heat. The universe would experience an astronomically high energy release if these massive black holes were to collide. The impacts of the collision will ripple through time and space, as predicted by Einstein's theory of relativity, but they won't be uniformly distributed. Research conducted after the gravitational wave detection in 2016 revealed that the waves originated from a black hole collision that took place 1.3 billion years ago. There were hardly any vegetation at this time, and no animals had ever evolved on Earth. This demonstrates that it may take these waves a very long time to traverse the immensity of space before being picked up by humans. Since the Laser Interferometer Gravitational Wave Observatory, or LIGO, discovered these waves, more LIGO facilities have been constructed all across the world to advance the investigation of gravitational waves in space. This will make it easier for scientists to catalog other black hole encounters that have occurred throughout the cosmos. Although the merger of the black holes in NGC 7727 will undoubtedly be chaotic due to their supermassive nature, it won't pose a threat to Earth because of their distance from our galaxy. Scientist Joseph Lazio claims that gravitational waves are too tiny to be concerned about. After example, it is very plausible that numerous gravitational waves have passed over the surface of the Earth in the past and even at the present, and so far, no obvious effects have been recorded. I appreciate you watching Zeey. Thanks, and we'll see you in the next video.